Welcome to one of the most impressive industrial recycling operations in the world. Every year, millions of vehicles reach the end of their lives. Cars that once traveled thousands of miles eventually become damaged, outdated, or too expensive to repair. But instead of ending up as waste, these vehicles begin an incredible transformation that turns them into one of the world's most valuable raw materials, recycled steel. Today, we're taking you inside a modern vehicle dismantling factory to witness the complete process of how scrap cars are carefully dismantled, sorted, shredded, melted, and reborn as high-quality steel. Every stage combines skilled technicians, powerful machinery, and advanced recycling technology to recover valuable materials while reducing environmental impact. The journey begins as trucks deliver hundreds of end-of-life vehicles to the recycling facility. Each vehicle is inspected and documented before entering the dismantling line. Although many of these cars appear beyond repair, they still contain dozens of valuable components waiting to be recovered. Before any heavy machinery begins its work, hazardous materials must be removed safely. Technicians carefully drain engine oil, transmission fluid, brake fluid, coolant, fuel, and air conditioning refrigerant. These substances are collected separately to prevent contamination and are either recycled or disposed of according to strict environmental regulations. Next comes the removal of reusable parts. Engines, transmissions, alternators, starters, radiators, wheels, doors, mirrors, electronic modules, batteries, catalytic converters, and wiring harnesses are carefully dismantled. Many of these components still have significant value and can be refurbished or sold as replacement parts, extending their useful life before recycling becomes necessary. One of the most valuable parts removed is the catalytic converter. Hidden inside are precious metals such as platinum, palladium, and rhodium, materials that are worth thousands of dollars per kilogram. Copper wiring is also collected separately because of its exceptional recycling value. After all, reusable and hazardous components have been removed. Only the stripped steel body remains. The empty shell is transferred to an enormous hydraulic crusher, capable of compressing an entire vehicle into a compact block within seconds. This dramatically reduces its volume, making transportation and further processing far more efficient. The compressed vehicle then moves toward one of the factory's most powerful machines, the industrial hammer mill shredder. Massive rotating hammers spin at incredible speed, tearing the compressed vehicle apart into thousands of small metal fragments. The sound is thunderous, as steel, aluminum, plastics, glass, and rubber are separated into manageable pieces. Once shredded, the mixed materials travel along a sophisticated network of conveyor belts. Powerful overhead magnets immediately attract and remove ferrous metals such as steel. Since steel is magnetic, this process efficiently separates it from the remaining materials. Non-ferrous metals like aluminum continue to another stage, where advanced eddy current separators use powerful magnetic fields to eject lightweight metals away from plastics, rubber, and other non-metallic materials. Optical scanners, air jets, and automated sensors further improve sorting accuracy, ensuring each material enters its proper recycling stream. Now comes the most dramatic stage of the entire operation. The recovered steel scrap is transported to a steel mill, where it becomes the primary raw material for new steel production. Huge charging buckets feed the recycled metal into an electric arc furnace, capable of generating temperatures above 1,600 degrees Celsius. Inside the furnace, enormous electric arcs melt the scrap into a glowing pool of molten steel. Any remaining impurities rise to the surface as slag and are removed, leaving behind high-quality liquid steel, ready for casting. The molten steel is poured into continuous casting molds, where it begins cooling into large slabs, blooms, or billets. As the steel solidifies, powerful rollers guide it through cooling systems before it enters rolling mills. Inside these mills, the steel is heated once again and compressed under tremendous pressure into sheets, beams, rods, or coils. Every pass through the rollers improves its strength, consistency, and surface quality. Advanced laser inspection systems continuously monitor dimensions to ensure every product meets strict industrial standards. The finished steel is then packaged and shipped around the world, where it will become part of new automobiles, skyscrapers, bridges, railways, heavy machinery, household appliances, and countless other products we use every day.